Hello everyone, welcome back. Let's talk about another medium problem on Leetcode today. Divide pairs into teams of equal skill, Leetcode 2491. In this problem, we are given a positive integer scale of even length n, where scale I denotes the scale of the ith player. Then we have to divide the players into n by 2 teams of size 2, such that the total scale of each team is equal. The chemistry of a team is equal to the product of the skills of the team players. And we should return the sum of chemistry of all the teams or return -1 if there is no way to divide the players into teams such that the total skills of each player is equal. Then in example 1, we are given skills as 3, 2, 5, 1, 3, 4 and output is 22 because first we divide the players into teams of 1, 5, 2, 4, 3, 3 where each team has total skill of 6 and then we calculate the chemistry of individual teams. So it will be 1 into 5, 2 into 4, 3 into 3 for these three teams and then sum them up. So we will get 22 and that will be our answer. Now in terms of solution, this problem is very similar to two-sum where we have to find two numbers, say x and y in the array such that their sum is equal to target. And we have already covered that problem on our channel. Please check it out here. But in this problem, we are not given any target. So we have to find what is our target. And then we have to sum up all the pairs in such a way that we find n by 2 such pairs such that their sum is equal to that target. And if any of them is not equal to that target, we will return -1. Now coming back to our problem, it is given that we have to form the team of size 2 such that the total skill of each team is equal. And to make that above condition work, let's take the weakest player, that is player with skill 1. So now in order to balance the team, who should this player pair with? And the answer is they should pair with the strongest player, that is 5 in this case, right? So how about we sort the array and then our array becomes 1, 2, 3, 3, 4, 5. Now we can actually use two-pointer technique that we employed in two-sum problem as well, where we take left and right pointers, left starting from the 0th position and right pointer starting from the end of the array. And we keep on building up the teams from the start and the end till the two pointers meet. And now the question is, what is our target? Initially, we can set the target by adding the scales of weakest player and the strongest player, and it will be equal to 6 in this case. So now we will just do the pair formation. So here we can see that the scale is 6. And what will this team contribute to the chemistry? It will be 1 into 5. And now we move to the next players. L comes here and R comes here. So we can see that the total scale is still 6. And what they will contribute to the chemistry? It will be 2 into 4. And then we come to the next layers. We come here and again the total scale is 6. So this is also a valid pair. And what they contribute is 3 into 3 to the chemistry. And now left and right pointers have met. So we are done. And we can calculate total chemistry as 22 and that will be our answer. Now let's code this up. So first we will sort the array to facilitate pairing. Now we will take two pointers left and right, one starting from the beginning and another starting from the end. Because we have to return long and we can avoid conversion, we can actually take all the variables as long from here on. Our target skill will be skill of the weakest player and skill of the strongest player. And let's also define our total chemistry, that is our answer, as 0 initially. So now we can start the loop to form the pairs. So the current pair skill sum will be equal to skill of the weakest player plus skill of the strongest player. And if it is not equal to target skill, that means skills have deviated, and in this case we have to return -1 because we cannot form the teams with the equal skill. Otherwise we will just update the total chemistry with the product of these numbers. So it will be multiplication of team player skills. And now we will update our pointers to form the next team and finally return total chemistry as our answer. So now let's run this code. Let's submit this code. So now in terms of time complexity, it will be O of n log n because we have to sort the array. And then when we are iterating on this array, that takes O of n time. But overall the time complexity says O of n log n. And in terms of space complexity, we are not using any extra space apart from this input array. So our auxiliary space complexity will be O of 1. And now the question is, can we do better? And the answer is yes. If you remember the two-sum problem, we actually use map to reduce the time complexity to O of n. And we can do the same thing here. So let's take the input from example 1 again. And now the question is, what will be our target sum? Let the total skill of all the players be x and number of teams be t. And because we want all the teams to have same target skill, each team's target skill will be x by t. And in example 1, we can see that total skill is equal to 18 and number of teams is equal to n by 2, that is 6 by 2 equal to 3. So our target skill for each team will be equal to 6. So now it again became like a two-sum problem where for each skill in the array, we will try to find remaining skill equal to target skill minus current skill in the array. And if we find one, then we can form a team. And at any point we cannot form a team, we will return -1 as our answer. For finding the remaining skills, we have to use hashmap here because that reduces the time complexity to O of 1. So now let's see this in action. First, let's map the number of players with each skill because we have to look up for the skills in the map, right? So we can see that skill 3 occurs twice and rest of the skills occur only once. So now we have built the skill map. So now the next thing for us will be just to go through this array and try to pair up the teams. The target skill for each team is 6 and first player has skill value 3. So remaining skill value to form the team with target skill is 3 and we can see that it is present in the map. So we will form the pair here. So the chemistry of this player will be 3 into 3, that is 9. And because we have used one of the remaining skills, we will reduce the frequency of 3 to 1. And why didn't we reduce the frequency of 3 to 0? Because it appears that we used 2 threes. And the answer is because we will see 3 again. So we will deal with the remaining frequency there. And if we try to deal with all the threes now, then we have to use some skill to index map, which will increase the complexity. So to keep the logic simple, we will just reduce the frequency of the skill that we used for finding the remaining skill. So to avoid this, we will again process 3 when we see it. But because of this, the product will become twice. So we have to divide our product by 2. But let's see this in action. So now the next skill is 2. So the corresponding skill that we have to look here is 4. And we can see that 4 is actually present in the map. So what will be the chemistry of this team? It will be 2 into 4, that is 8. So because we use remaining skill 4 from the map, we will reduce its frequency by 1. And now we don't have any 4 remaining in the map. So now the next skill is 5 and corresponding remaining skill we require to form the team is 1 and we can see that 1 is actually present in the map. So we will pair them up and now the chemistry of this team will be 5 into 1 and now because we have used 1, the frequency of 1 becomes 0. So then we come to 1 and the corresponding remaining skill is 5 and 5 is actually present in the map. So we will form a team of chemistry 1 into 5. And now because we have used 5, we will reduce the frequency of 5 to 0. Then we come to 3 and corresponding remaining skill required is 3 and 3 is actually present in the map. So the chemistry score of this team will be 3 into 3 and now we reduce the 3's frequency to 0. Then we come to 4. We can see that the corresponding remaining skill for 4 is 2 and that is also present in the map. So we will calculate the chemistry score of this team. So it will be 4 into 2 and now we have used skill 2 to form the team. So we will reduce its frequency to 0 as well. And now we are also done with the skill array. So we will sum up all the chemistry scores, but we can see that they occur twice. For example, 2 into 4 is same as 4 into 2. So we will divide these sum of products by 2 and that will be our answer. So now let's jump into the code part. So first thing we will do is we have to figure out the target skill and that will be equal to sum of the skills array divided by number of teams, that is n by 2. Now let's calculate the sum of the skills array. So if this sum is not divisible by number of teams, then we cannot evenly divide the skill in n by 2 team pairs. So we will return -1 in this case. Otherwise, our target skill will be equal to sum divided by n by 2. Also, we need the frequency map. We can build it when we are calculating the sum of skills itself. Now to update the frequency of the current number, we will get current frequency from the map if it is present. Otherwise, we will get 0 and increment the frequency by 1. And now that we have built the frequency map, we will try to calculate the total chemistry. That is our answer. So we will again iterate on the skills array. So first thing we will check is what is the corresponding remaining skill. and that will be equal to target skill minus the corresponding number. And if at any point map doesn't contains that key or the frequency of the skill is less than equal to 0, then that means we cannot form a pair. So we will again return -1. Otherwise, we will use this remaining skill to form the target skill and reduce its frequency by 1 and update our total chemistry. And it will be equal to sum of product of current number into remaining skill. And finally, instead of returning total chemistry, we will be returning total chemistry by 2 because we have duplicates of products. So that will be our approach. And now let's run this code. Looks like RAM skill should be integer, so let's make it integer. Also, to avoid incompatibility, let's convert target skill to integer as well. And here let's convert the product of these numbers to long to avoid the overflow. So now let's run this code again. Looks like compiler is complaining about lossy conversion from long to int. So let's explicitly convert it to integer. So now let's run this code again. Cool. Let's submit this code. Awesome. It looks very slow compared to our sorting based solution, but the time complexity here is O of n because first we are looping through this skill array to calculate the sum and to build this frequency map. And then we are again looping on the skills array to form the pairs. And because of this, the time complexity is O of n and the space complexity is also O of n because we are using this additional map to store the skill frequencies. So that's it. And in this problem, I preferred sorting based approach because that was cleaner to write. But that is up to you. And I hope this video was useful to you. If it was, please like, share and subscribe. The code link is in the description below. If you have any questions or comments, please write them in the comment box. Thanks for watching. See you next time.